what is the ether? And I'm not talking about the stuff you smell. Okay, I'm talking about this stuff that people think is responsible or underlies gravity, underlies electromagnetism, maybe even light, right? And one fellow says the following, and I like to define the ether as really an aetherist. I like to define an ether as a person who doesn't have the slightest clue what the ether is. That's the best definition of an aetherist. Because if he knew what the ether was, he wouldn't be proposing the theories that he proposes. And here we have our first aetherist. He says, the black sky we see in the ether made by threads and ropes. The black sky is made, meaning space, it's made out of threads and ropes. I don't think so. Change the word matrix with ether. So they just say ether's everything. Okay. The matrix is everywhere. In other words, it's everything, right? It's like God. He's everywhere. He's everything and therefore nothing. It's all around us, even now in this very room. Okay? You can see it. Bartender, I would like to have whatever he had, you can see it when you look at your window or when you turn on your television. Okay. I don't know what he's seeing, but I don't see the ether. I see images of different kind. I can point to it at all times. Good. If you can point to it, draw it. Very simple. If you can point to it, draw it. That's how simple it is. And so these people don't do that. And that's where I have a little bit of problems with them. Okay, so here we have different versions that you will find if you put this in Google Images. You'll get something like this for the luminiferous ether, okay? And what do you see? Well, what you see is a bunch of lines, arrows, okay? And if you zoom in on that, okay, you get something like this. More or less, they all say the same thing. This is what they're all pointing to. If I can get it up here. It looks like that. That's your luminiferous ether. Okay, so if you ever wanted to know, that's what it looks like. And so what are you staring at? Well, you're staring at a bunch of points that form arrows, and they're all going one way. And that's part of the problem, right? The ether can only go one way. And so you got to do kind of miracles to use this to explain both gravity and electromagnetism. That's one of the issues. Okay, it only goes one way. Okay, so what are we staring at? What are those arrows? What are those points that make up the arrows? What is this? And that's part of the problem. And usually they're referring to vector, magnitude, and direction. That's what the arrows usually represent. And that means that they're going to be doing math. They're going to represent it mathematically and put these arrows ad hoc, like, here's my arrow. Okay, so are all the arrows the ether? Are all the points the ether? What's the ether? And they never defined it. They never really pinpointed what the ether is. In other words, they never drew it, because if it's a physical object, you just can't draw it. That's how simple it is. And so we have to start at the beginning. What is the ether? I've already explained this in the past. And here you have, you have the, let me get this right. Okay, there it is. You have Mr. Aristotle there on the lower left. And what do you think of the ether? Well, all of them thought of them as particles. These were, ether means air. It's the air of the gods. And they always thought of air as particles. And the only was, whether there was space between the particles and whether there is anything such as space, whether space exists, and whether there's movement, whether the particle had a place to move into. These were the issues they talked about. You have to remember that Democritus, and even before him, Leucippus, they were, over 100 years, they came over 100 years before Aristotle. And so, they already discussed particles. They said that all there is atoms and empty space. Atoms meaning particles. This is how they viewed it. And so they did talk about particles in those days. And they thought of this as particles. There was a debate, but they all debated about particles and whether the particles had a place in which to move. So the ether was thought of as particles, but as particles that the gods breathe. That's more or less the notion. And certainly in the 19th century, when you have all these waves, electromagnetic waves, they were trying to figure out what light is. What was it? Well, it was the undulation of all those particles. Went up and down, all these waves, the standing wave of particles. That was more or less the notion they had. And that survived until today, because here you have the quantum version, okay? And this, I can't remember exactly where I got this from. I'm sorry about that. I usually put the reference. It's either Wikipedia or maybe even from one of the physicists out there, mathematical physicists. And what is he saying? They're saying modern science does not equate vacuum with nothing. This is going to be important for the next subject, which is the multiverse. Okay, so they're saying vacuum is not always nothing, or sometimes they do, sometimes they don't. And some people do equate the vacuum with nothing. They say that it's the ether. And some people make a separation and think of space as a container of ether. And so you have to be careful with which group you're talking to. You're talking about at least the ether, right? It says, indeed, the vacuum in quantum field theory is filled with what? Virtual particles. Okay, so it's filled. That means that they separate, or they distinguish between the vacuum, in other words, space, nothingness, and what's in it, which are all these virtual particles. And I'm assuming if they're talking about particles, they're talking about some kind of corpuscle, and each one has to have shape. That means each one is separated from the next one by what? Well, hopefully by space, because they have to identify what separates one particle from another. And there you see it on the next slide. It says the quantum vacuum is often viewed as a modern version of what? An ether theory. So yeah, the quantum, they never abandoned the ether. The ether survives until today. They call it the space-time. Other people call it the false vacuum or the quantum vacuum. They're talking about the ether. They're talking about a space filled with particles. That's what ether has always been. And then you see there, it says a space consists of selected mathematical objects that are treated as points. What are points? Particles. That's what they mean. But they use the word points because they're going to talk about it mathematically. And mathematically, what is a point? Well, it's a number, a value. That's what a point is. And they say the nature of the points can vary widely. For example, the points can be elements of a set. Again, what are they talking about? Numbers, functions on another space, or subspaces of another space. Now, they're talking about numbers. They're not talking about physics. Okay. It is the relationship that defines the nature of space. Okay, so you can see that quantum really treats, the vacuum as full of particles. And that's what the ether has always been. That's the notion of the ether theory. Okay. Here, just to rub it in, here we have a Nobel Prize. His name is Robert Laughlin. I've touched upon him a couple times. And he says the following: the modern concept of the vacuum of space, right? Vacuum of space. I thought vacuum and space were the same thing, but he says the vacuum of space, confirmed every day by experiment, is a relativistic ether. But we don't call it that because it is taboo. Yeah, you can't use the word ether, but they never abandoned ether. From the days of the Greeks all the way to today, ether, bunch of particles, it's always been the same thing. Some equate the particles, the ether with space. Others say, no, the space contains the particles. And others, like the other fellow the other day, he said, no, ether is neither. Ether is potential. Okay, so we don't know what the ether is. And again, I like to say that an aetherist is a person, the best definition, right, is an aetherist is a person who does not have the slightest clue what the ether is. And if he did know and he's going to treat it as an object, he's just got to draw it. He's just got to put it up there for us to see. Okay, and so here is the difference. For those of you who can't tell the difference, some people say that my threads, my ropes, they're the ether. Haven't discovered anything new. So here I put them side by side so you can distinguish. If you have eyes, you'll be able to tell the difference. Here it is. The ether is the guy on the left, and a rope model, which is a single thread in the entire universe that weaves all the matter and all the ropes that interconnects every single atom. That's the one on the right. Okay, so is the one on the left the same thing as the one on the right? Well, hopefully you say no. Otherwise, you need to see an ophthalmologist. Okay, you got a problem with your eyesight. Okay, so no, the ether is not the same thing as the rope model. We have no place for a bunch of particles. That's what the ether is. If you think the ether is something different, draw it. Don't tell me I'm wrong. Draw it. And that's exactly what this fellow said. A second fellow, he's been at this for over a month. He says the following is, why the freak? Who the freak cares about Greeks' thought on the ether, what the ether was? They never saw the ether. Yeah, they never saw it. They never claimed to see it. They didn't even know what air was. Yeah, they thought of air as particles. Okay, and that's quite clear. Okay, they didn't even know what air was. He says, you're just as stubborn, arrogant, as despicable, narcissistic as your twin brother Ken Wheeler. Please, come on. At least they got a little more hair than he does. So long, Bill. Unsubscribing. Well, sorry to see you go. Not because of the subscription, but because you are abandoning with your tail between your legs. I thought you were going to take this to the end. I thought we were going to really have a discussion here. After all, I'm putting your theory here, on the line, and I'm discussing it. It's not like I'm avoiding I'm showcasing your theory. And so, for him to abandon and leave and run away with his tail between his legs, it's because he cannot answer the questions, okay? And I've been, torquing the screw more and more, trying to get an answer from him. And one of the questions that I asked him is, what does the ether look like? I think it's a valid question. I'm asking, if you're going to treat ether as a physical object, you say it's a thing, okay, draw it. Illustrate it so that we know what you're talking about, what's going through your head. I'm saying it's a bunch of particles. You said it ain't. Don't raise straw men. Okay, we conceded. You want to call the ether whatever you call the ether, no problem. Make a picture of it. Show us what you're talking about. Well, after 1 month, he did come through and he came with his ether blob. See if I can put this up here for you. This is the notion of the ether, okay? And he says, that's the ether. Here, I'm drawing ether for you. Okay, so here's the red ether blob. That's what he refers to as the ether. Okay, then he explains, he said the ether goes in the South Pole, it comes out the West Pole or the East Pole, I don't know, one pole, and where's surrounding ether, it bends back towards the South Pole again, Taurus. Okay, in the case of a magnet, it's obviously a loop. In the case of gravity, ether goes into an atom and exits and enters the next atom, and so on. Okay, that's how he visualizes this thing. This is what determines the flow of ether. He's talking about the flow of flow, or what I call the flow flu, or the flu flow. It's a fluid flow, or the flow or the fluid. The flu flu. Woodchuck, wood, seashells by the seashore. Okay, I'm back here. Okay, this is what determines the flow of ether. Great. And whatever medium that pleases you. No, it's not a pleasing me. You got to tell the story. You're giving the presentation. Okay, and of course, how masses appear to attract each other. I've been working on this for many years. Okay, so what's the problem? What he's showing there? Well, he's showing 3 things at least, if not 4. Let me point them out to you. There's a blue stuff. And he's saying that the ether is space as well. So there is no contrast between space and ether because he's saying that space and ether are the same thing. So I need to know what the blue stuff is if the red ether is both ether and space. What is the blue stuff then? That serves as contrast. And of course, they never get to that point because they say, oh, Bill, you're just doing word salad, semantics. Now, you got to tell me what the blue stuff is because you're giving your blob contrast. That's the first one. The second one is that you see those hexagons that build the whole shebang, which is the whole blob. If the whole blob is the ether, you got to tell me what each one of the hexagons is, not to mention each one's the lines that comprises the hexagon. You got to identify each one of those things. You can't just say, there it is. You know, you got too many things in that picture. You got to identify each one. Okay? And he doesn't do that. And so he says they're all one. The blue stuff, the red stuff, the hexagons, the lines that comprise the hexagons, all of it is the ether. And yeah, when you cover all the bases, you know, so that nobody can challenge your object, the thing that you're presenting, your hypothesis, which are the objects that you must present, and your definitions, if they're all the same, well, yeah, it's like God. God is everything. And yeah, you can do many things, many magic tricks if God is everything, if your blob is everything. And so, yeah, and this is his blob in motion. Okay, this is how he presented it. Okay, you can see how it's moving. Okay. And so he's saying, yeah, this is the ether in motion. And again, we need to identify what the blue stuff is. We need to identify what the hexagons are, why one hexagon is separated from another, what the lines are. You got to identify each one, explain each one, or draw each one separately. You know, draw a line and tell me what each line is. Draw a hexagon and tell me what a hexagon is. And then draw the blob and the blue stuff. Identify those as well. And he doesn't do that. Of course, he says, there's your blob. You want a drawing? There it is. Okay, so we know what it looks like, more or less what he has in the back of his mind. Okay, so what is the trick? With this, he's got to explain what we asked him to explain, and that is this. Here we have, okay, a spoon, and I'm going to let go of it, and it falls downwards. We call that effect, that phenomenon, we call it gravity. Okay, no biggie. I think we're all familiar with it. Here's an illustration of that. You see the spoon falling downwards. What does he have to explain? Well, he's got to explain why is the spoon coming down in the case of gravity. This is gravity, right? And so you would think that there's either push from above or pull from below. Something is in contact with a spoon that we can't see or touch. He's got to make that thing visible for us because something is in contact with a spoon. Otherwise, we're introducing black magic and saying it's done by remote control. God does it. Angels do it. Spirits do it. Okay, you can't do that. Not in physics. The way it works in physics, you gotta make visible the invisible, intangible objects that is pulling or pushing on the spoon. And as far as I'm concerned, there's only push or pull. Okay, but this fellow, he invented a new form, or he thinks he invented a new form of contact, of physical contact. He calls it entrainment. What in the world is entrainment? Well, entrainment means push. You're carried with the flow of you're in a river, and a river carries you because it's pushing on you. So he calls that push, which he equates with the Venturi effect, where you have this constriction in one place, and that forces you to go faster in a given region, okay? And he calls that entrainment. Fine, but entrainment is push. That's all it is. All you've done is push. So you're not pulling, you're pushing. You're just being carried by the river. And he never understood that in his many years of studying the ether, okay? So he says, no, it's neither push nor pull. It's entrainment. Okay, we call it push in science, okay? And there it is. He says the spoon is being pulled downwards, I guess, or pushed from above. Here I'm illustrating pull because he says that the ether is between atoms. So here supposedly we have the atoms of the earth on the bottom and a spoon on the top. The ether is between them, and somehow this entrainment, this river, is pulling the spoon downwards. That's the best I can explain it from his point of view. If he doesn't agree with it, well, he can come back and clarify for us what I'm interpreting wrong. Okay? So I can't tell you what is going through his mind. All I can tell you is that this is what he's describing. And again, it's a description. And I'll tell you why. Give me a second here. This computer works a little slower. Okay? And here, let me show you why. Because this is the equation of the Venturi effect. The Venturi effect has this equation. Pressure at a position 1, pressure at position 2, density of the fluid, right, and velocity of the fluids. That's what the equation is for the Venturi effect. What is all that? That's just an equation. What's an equation? A description. Venturi effect is not an explanation. He doesn't understand the difference between an explanation and a description. And of course, he's going to say, Bill, you're just doing semantics. You're just doing word salad. What you have is a description. We have no explanation of what causes, what the mechanism is. All you're saying, if I press here, it flows faster. There's more density over here and it flows faster. That's all he's saying. He's not explaining why it flows faster. He's just saying it does. And that's the Venturi effect. It's just a description, mathematical description. He never understood that. Much like the flat earthers, they talk about, gravity being density related. Okay, density is not an explanation. Density is a description. There's more over here than over there. Why does it go from more density to less density or vice versa, whichever one you like? You got to explain that. You got to explain the flow of matter. And hopefully the matter doesn't just flow because it likes to flow. It flows because something is pushing on it or pulling on it. If you don't put push or pull, if you don't have physical contact, you're doing black magic. It's just as simple as that. Okay, so what did I ask this fellow to do? And he hasn't done that. So again, I got to do it for him because he says the blob, this ether thing, is between two atoms. Okay, so I put two atoms in there and I said, okay, show me what's in between the atoms. Okay, so he's going to put his ether blob. Okay, here it is. That's what he put in there. Okay, he's put his blob. Okay, and so I said, okay, let's see. Same with this. He's going to produce pull, I guess, because one atom goes towards the other. I would think that's pull. I'm not sure how you can turn this into push. Okay. Here's another version of this. Give me a second here. Okay, maybe it's like that, sideways. Okay, I don't know how he's going to put his blob. It's up to him to tell me how he wants his blob put in there. Just in case, I did push as well. Okay, here's push. Okay, the blobs are on the outside pushing each particle inwards. I don't know if this is the one that he's referring to. Probably not. Okay, just in case, I have another version of that one as well. Here it is. Okay. Hold it. Here it is. Give me a second. Like that. Okay. So you have all these versions of push and pull. Just in case, I put another version. Here it is, where the two particles are within the blob. Okay. So maybe it's something like this. And again, all I can do is look at the possibilities based on what he explained. And he says, so far all we have is description. We have no idea why one particle is pulled towards the other. He says, I put the blob in there. It's self-evident. Do you understand? No, we don't. Okay, we don't understand because you haven't produced it. You haven't shown me why one particle is going towards another, especially in a straight line rather than going around. That's one issue. Here's another version of this one, just in case. So, I try to cover all the bases. Give me a second here. Okay, that's another version of it. I don't know which one he wants. It's up to him. I don't know if he's got a version that I have not put here. Here's a third version of this. Okay, like that maybe. I don't know what else to do. I'm putting it in every way that I can imagine that he's going to produce pull or push. I don't know. I guess he's doing pull of some kind, or maybe they're pushing from the outside. I don't know. He's got to tell me which of these scenarios is the one that he proposes. And I want to clarify one more time. The black stuff that you see in the background, he says that's ether too. It's a static ether while the other ether moves. It's like we have a shearing effect where you have the black, which is standing still, and the other ones that move. He has to justify that. He says it's all the same stuff, which clearly it ain't. Again, you see the hexagons. You see the lines making up the hexagons. All that's got to be clarified, what he means by each one of those things, because these are all different things. And so he's got like 4 different things there aside from the atoms. He says the atoms are also made of the stuff. So there is no difference between the ether and the particles also, even though he's got a shearing effect between the black stuff and the stuff that's moving, the red and blue stuff there. So I don't know. It's up to him. He's the guy who's got to tell us what his mechanism, his proposed mechanism is. I cannot put words in his mouth. He's got to put words, into the screen so that we can see his mechanism. Okay, and all I can do is illustrate what he's talked about, and that's all I can do. Okay, so here we go back to his original, and there it's not in motion, but this is the blob. This is what he presented. I took a snapshot of it as opposed to it running, because we need to first identify the object. We can always put it in motion later on, and you can see that what he's got to identify. He's got to identify the blue stuff, the blob, the whole shebang of the red stuff. He's got to identify the hexagons that form, the many hexagons that form the blob, and also the 6 sticks that form each one of the hexagons. But at least the hexagon's got to be justified. That at least. If he doesn't want to justify the sticks, we can let him off the hook. But he's got to justify the hexagons and the blue stuff. Okay, and so the ball is in his court. And I think it'll be forever in his court, because he put his tail between his legs and started running.